Okay, so in this video I'm going to go through question 4 from the January 2015 exam paper. There's been quite a few questions on from students about how to sort of deal with this question, and then there's a lot of sort of confusion about using the gradually varied flow equation when you're using it as a mean, or when you're just doing it without taking the mean of the top and bottom values. So I'll explain, and I'll do both methods in this video. So I'll use the gradually varied flow equation using the mean method, and then without using the mean method, and I'll show you the difference in the answers you get, and then I'll give you an explanation as to why there is a difference. I think, like I said in previous videos, the both answers are correct, so the method you use doesn't really matter. So if you use one method and get an answer, and you use another method and get a different answer, you'll still get full marks for the question. So all you need to do is just be confident in the method that you choose, and then be confident in remembering the equations, and then creating the table for the gradually varied flow problem. So question 4, part A, is 5 marks, and that says discuss advantages and disadvantages. I'm not going to go through that. There's a lot of literature available on that, so that's fairly easy, and it's 5 marks. I'm going to do the analytical part, which is majority of the marks for this question. And in part B it says a trapezoidal channel carries a flow of 90 meters cubed per second, has a bottom width of 3 meters, side slopes of 1 vertical to 1 horizontal, a bed slope of 0.0015, a Manning's n value of 0.017. It says a dam is constructed that increases the depth immediately upstream to 4 meters. Carry out one step of integration using the direct step method to find out how far upstream the depth is 5% greater than the uniform flow depth, and that's 15 marks. So to make you understand what the question is asking, I always find it easy to draw sort of the problem out. So what he's saying, just draw it here. So this is your dam. Yep. And then there's a flow over the water, and if this is your bed slope. Yep. Now it says immediately upstream of the dam the water depth is 4 meters. So it's saying the depth here is 4 meters. Yep. And it says how far upstream will the depth be 5% greater than the uniform flow depth. And I explained this in the lecture. This surface profile here will have been flowing at normal depth, a value of x upstream. So let's say normal depth was here, and that might be you could say 1 or 2 kilometers away from that 4 meters. So it will be far upstream that this was at normal depth. But because of this dam, the surface profile has changed, because the dam is now influencing the surface. So normal depth, the flow will not be flowing at normal depth anymore. It will be flowing at a different value all the way here. You'll have different y values until you get to here where it's 4 meters. Now the question is saying carry out one step integration using direct step method to find out how far upstream the depth is 5% greater than the uniform flow. So if yn is here, you'll need to calculate yn plus 5%. So you might find that the yn you're calculating, the value you need is here, a value of x. Yep. So that's all the question is asking you to do, is sort of start integrating from here and move backwards until you're at 5% more than the normal depth. Yep. So the first thing you will have to calculate is the normal depth, and for this question the channel is trapezoidal, so it's a trapezoidal channel, and it says the side slopes are 1 horizontal to 1 vertical, so it's 1 1. Yep. So here x, which this side is x, so x is equals to 1. Yep. And then the equations for area and wetted perimeter for a trapezoidal channel are different. So B, this is B here, which is 3 meters, and this top width B is big B. You need to be careful when if the question says trapezoidal channel. Yep. So that's the problem, and then the first thing we need to do is calculate yn. If I did this table here, which shows you the equations for the different cross sections. So for a rectangular, it's giving you area, wetted perimeter B, which is the top width here, that one there. For a rectangular channel, it's B is equals to B because this width here is the same as that width there. But for a trapezoidal, this width is not the same as that width, so that's why there's a different equation for B. So that's big B. Yeah. So that's big B, which is this width here. Yeah. And then again, area, wetted perimeter, and then the hydraulic radius are different for a trapezoidal and a rectangular, and for a circular. We won't be concentrating on these, so you don't have to remember these for the exam. The two you'll need to remember is this one, rectangular and trapezoidal. So those are the two equations. So those are the equations for those two cross sections that you will need to remember. So let's go and answer the question. So I'm just going to quickly write down the parameters that are given. So Q equals 19 cubed per second. B equals 3 meters. So if you've seen in the equation x, yep, so this is x here. So in our question it says 1 vertical to 1 horizontal, so in our question x is equals to 1. Yep. So I'm just going to put here x to 1, s is equals to 0.0015, and n is equals to 0.017. Yep. So the first thing we need to do is calculate yn. So that is given by Q equals 1 over n, area to the power 5 over 3, and wetted perimeter to the power 2 over 3, and then times slope to the half. That's the equation. Now, because you need to calculate yn like normal, you can't rearrange the equation for y, so you have to use a trial and error method. Yep. So the equations for A and P first are B plus x y y, and for wetted perimeter it's B plus 2y square root 1 plus x squared. So those are the two equations for area and wetted perimeter. So now the aim is to put in the values and keep trying values to work out what the value of y is. So you do Q equals, so if I put in the values again, so if I get rid of that actually, so if I do 19 equals, which is Q, 1 divided by, oops, 0.017 times that by, so I've got 3 plus 1, which is x, times y, which is unknown, we try to work out, times y, and all to the power 5/3. And then wetted perimeter is 3 plus 2y, again y is unknown, 1 plus 1 squared, all to the power 2/3. And then times 0.0015, which is the slope, to the power of half. So now the aim is that you calculate or use a trial and error method to calculate what yn is. Now, once you've done that, you'll find that yn is equals to 1.725 meters. Yep. And then I've just rounded it to 1.73 meters. So that's the value of yn you will get through a trial and error method. So the aim is that you try and run values, so put in 2, see if you get 19. If you don't get 19, then reduce it to 1.9. If you don't get 19, then 1.8. So this trial and error method is similar to the open channel flow material that you did. So you should be fairly confident in solving the Manny's equation using a trial and error method. We've done it a few times, so I'm fairly confident that you can do it. So you should also be confident. Now the question says that the calculate where the depth is 5% greater than uniform flow depth. Yep. So what you should find, what you need to do is now calculate yn is equals to 1.73 plus 1.73 times 0.05, and that gives you 1.81 meters. Yep. So that is the normal depth plus 5%. Yep. So you're integrating from 4 meters up to 1.81. Yep. So that's the first part of the question, and that is a bit again, you need to know these equations. Yep. Now the next part is to start creating the table. So I'm going to do this in 2 methods. The first method I'm going to do is just I'm going to do delta x is equals to delta y 1 minus f of r squared divided by s naught minus s of f. So that's one method. Yep. The other method is delta x is equals to delta y 1 minus f of r squared s naught minus s of f, but this is mean. Yep. So in this method, method 1, I'm not going to take the mean of the top and the bottom, but in method 2 I'm going to take the mean of the top and the bottom, and then you'll see the differences in the answer. Both methods are correct. You just need to be confident in choosing one method. Yep. So if you do this method first, if you do method 1, so again if I put we specify, and this is just the direct step method. Yeah. So in the lecture handouts, they shows you that method and that method. So just have a quick review of that, but this video should help you. So just going to get on another slide and start creating the table. So first value is x. Just do that. So 0. Y is 4 meters because we're starting integrating at y. Next is area. So the equation for area equals b plus x y. So you get 3 plus 1 times 4 times 4, and you get 28 meters squared. So area is 28. P, which is the wetted perimeter. Again, you need to know the equation for wetted perimeter is b plus 2y square root 1 plus x squared, and that gives you 3 plus 2 times 4 times square root 1 plus 1 squared, and that gives you 14.31 meters. So the value here is 14.31. Now f of r squared. Now because it's a trapezoidal channel, we're going to use the generic form of the Freud equation. So it is q squared b g times a cubed. Now I've had questions on what Freud equation to use, because sometimes you get f of r squared v squared over g times y, and you should be confident in manipulating this equation, and I've did it on the board in the lectures a few times. So you can substitute q v into this equation by knowing as q, because you know v equals q over a, so you can sub that into this equation and get this equation in forms of v. For a rectangular channel, you know b, big B is equals to small b, yeah, so it will cancel out with the b at the bottom, yeah, whereas here it doesn't cancel out because big B is different, yeah, because this value is different to this value, whereas in a rectangular channel, because that length is the same as that length, this b cancels out. So you should be confident in manipulating this equation, and we've done it a lot of times on the board, and I've showed you how we've got from this to the different variants. So you should be confident in manipulating that equation. So for this problem, the first thing you'd need to work out what b is, what big B is. So again, you need to remember the equation. So for the equation for b is b plus 2xy. So b equals b plus 2xy. So you get 3 plus 2 times 1 times 4, and you get 11. Yep. So finally f of r squared is 19 squared times 11 over 9.81 times area, which is 28 cubed, and the value you get for that is 0.0184, and then you do 1 minus f of r squared, So it's 1 minus this value, so you get 0.9815, and then you calculate your slope. Again, frictional slope is given by Manning's equation. Q equals 1 over n, area to the 5 over 3, p to the 2 over 3, s to the half. So if you rearrange this for s of f, you get q squared n squared p to the 4 over 3, and then area to the 10 over 3. Yep. So if you put in the values, you get 19 squared times n, which is 0.017 squared times 14.31 to the power 4 over 3 over area, which is 28 to the power 10 over 3. So if you calculate that, you'll get 0.0243. Yep. Then it's S naught minus S of F. So S naught, which is 0.0015 minus S of F, which is this value. If you calculate that, you get 0.00144. Now the aim is just to calculate delta x. Yep. So we're going to use this equation first. So delta x. So delta x equals delta y. What is delta y? Yep. So the question said from 4 meters. So from 4 meters to 1.81. Yep. So the change in height is 4 minus 1.81. So that's delta y. Yep. So delta y, 4 minus 1.81 equals 2.19 meters. Yep. So delta x equals to 2.19 times 1 minus f of r squared. So you get 0.9815 divided by 0.00144, and the value you get for that is 1492.7 meters. Yep. So depending on how many decimal places you take after these values, you should get a value of around that. Yep. So it's saying 1,492 meters from the dam, the depth, the water depth will be 1.81 meters, so that will be 5% more than the normal depth. So all this will give you the 15 marks. Yep. So you get the 15 marks for this question if you were to do that method. Yep. However, if you were to now, instead do this, take the mean, and this is sort of shown in the solutions on the VLE as well, you'd get a different answer, but again that method is correct. But I'm going to show you how that method is works again. So again, create my table. So value of x, so it is 0. Yep. Value of y, so I can just copy majority of that table. I can copy the first line of this table over, majority of it, sorry, not all of it. So the first line is 4, so area is 28, wetted perimeter is 14.31, f of r squared is 0.0184, 1 minus f of r squared, this is where we're going to take the mean, so I'm just putting here mean, s of f can copy that 0.123, s naught minus s of f, this is again going to be mean, and then finally delta x. Yep. So to work out the mean value for this one and this one, you have to do another row, but in this row you'll do 4 and you'll come down to 1.81. Yep. So now you'll calculate area again. So area will be, again the equation will be 3 plus 1 times 1.81 times 1.81, which gives you 8.706, and then again wetted perimeter P, so P will equals, so 3 plus 2 times 1.81 square root 1 plus 1 squared, and then that gives you 8.119. Then again you work out your f of r squared, which is given by the same equation, q squared b g a cubed. So you work out what b is. Yep. Big B is equals to the same equation, 3 plus 2 times 1 times 1.81, and you'll get 6.62 meters. So you calculate f of r squared, so that's 19 squared times 6.62 divided by 9.81 times 8.706 cubed. And then f of r squared is 0.3691. Yep. Now for this column here, we're going to take a mean of these two values, that value and that value. So for 1 minus f of r squared now, so 1 minus f of r squared is equals to 1 minus 0.0184 plus 0.3691 over 2. Yeah, so we're taking a mean, and once you do that you'll get a value of 0.806. that sits in between these two values. Yeah. So that's taken the mean value of f of r squared. Yeah. Now s of f again is the same equation. So again, your s of f is equals to 19 squared times n squared 0.017 times wetted perimeter 8.119 to the 4 over 3, area 8.706 to the 2 over 3. So your s of f value you'll get is 0.001254. Oops. And now for this column, you're going to take the mean. So you're going to do S0, which is that 0.0015. So S0 minus S of f equals, so you're going to do 0.00. We'll start on another sheet, to be honest. So just do it on here. So S0 minus S of f, you're going to get 0.0015 minus, so again it's going to be the mean value of that value and that value. So you do 0.543 plus 0.01254 over 2, and the value you get for that is 0.00845. That sits in between this value. Yeah. So now you've got a value for 1 minus f of r squared mean and S0 minus S of f mean, and it's mean because it's based on these two values and then these two values, so you're taking the mean of them two values. Yeah. So now when you're doing delta x, you do again delta y is 2.19. Yep. But this time you do 1 minus f of r squared, so it's 0.806 divided by 0.00845, and the value you get for that is 2088 meters. So you can see the difference straight away. So for this question you got 1492, and then if you take the mean you get 2088. So this answer is more accurate, but both methods are fine. So if you want to take the mean, and then taking the mean is fairly straightforward, there's nothing difficult. Yeah. And or if you just want to do a single row and just get delta x, that is also fine. But hopefully this video should have clarified using this method, which just takes the literal values, or using this method which takes the mean values of the top and bottom part of the equation. So both methods are right. So if you want to do this, all this would give you 15 marks, getting up to that 1492, and then again all this would give you full marks, getting to that 2082. So just choose one method. Either you want to choose the mean method, so you'd start off by doing the first row, and then you do the second row to get f of r squared again, to get s of f again, and then to take the mean to calculate the values in these two columns. Yep. Or you can just do a single row and get an answer. So both methods will give you an answer. Obviously this answer is more accurate, but in the examination, both, if you do both and get the correct answer, you'll get 15 marks. Yep. So just be confident in which method you want to use. If you want to use the mean, use the mean. If you don't want to use the mean, don't use the mean. But just be confident in either method. So that concludes that video. Hopefully it's been helpful.